Hi everyone, welcome to Cloud Computing series. In this video, we will be learning about grid computing infrastructures. See, in the beginning, people used the internet mainly for simple things like a remote command access. For example, using a telnet to control a computer from far away. Then came the web, which made it easy to view websites and share content using HTTP. Now, with the grid computing, we have taken a big step forward. Many computers in different places can work together at the same time, like a one supercomputer. Grid computing enables multiple remote computers to work together on a complex problems. See, grid computing means many computers, even if they are far apart, can join forces to solve big problems. It's like creating a virtual team of computers to handle tasks that are too big for just one machine. Then, unlike a simple remote access, applications actually cooperate and compute in sync. That means with a remote access like a telnet, only one user controls the distant computer. But in a grid computing, many applications run together on multiple computers and share the work. Then next is economic impact. Forbes magazine has projected the global growth of the IT-based economy from $1 trillion in 2001 to $20 trillion by 2015. So the IT industry has grown very fast. See, this huge growth is partly driven by the evolution from internet to web to grid services. That is, a lot of this growth happened because technology kept improving. Moving from the basic internet to websites to grid computing helped businesses and researchers work faster and smarter. Then next is, see, grid computing allows people to share a computer power and resources over a long distances. It's especially useful when working with scientific research. For example, climate models and space simulations. Then in big data, like analyzing massive amounts of information. And then in business applications, for example, in financial modeling and simulations. Then moving to the next, computational grids. See, like a power grid, a computing grid provides a shared infrastructure combining computers, middleware, special instruments, people, and sensors. Means just like electricity flows from a power grid to your home, a computational grid lets people use shared computing power from many connected systems. It combines hardware, software, along with the people to work on a complex tasks together. Built across lands, WANs, or internet can span a regional, national, or a global scales. That is, these grids can work over small networks, big networks, or even the entire internet. That means grids can connect computers from the same room, different cities, or even a different continents. Then next, components and access. See, grids integrate workstations, servers, clusters, and supercomputers. A grid uses many types of computers, normal desktops, high-end servers, computer clusters, and supercomputers, all combined to solve big problems. PCs, laptops, and PDAs can be used to access the grid. That is, we don't need a supercomputer to use the grid. We can use any basic device like a PC, laptop, or a smartphone to connect and use its power. Then, seen as a virtual platformer that supports a virtual organization. That is, the grid acts like a virtual teamwork platformer where different users or groups share computing power and data to do research or projects together. Example structure. See, this is an example for a computational grid built over a multiple resource sites owned by different organizations. Here, one grid can have computers from different universities, companies, or labs working together. Each place contributes its own machine. See, these sites contribute to different resources like regular computers, that is workstations, and powerful Linux clusters, big servers, or even a network of small processors to help out. Networking infrastructure. See, grids don't need a special network. They run on the same internet or a broadband connections that we already use. See, then it presents the entire grid to users as a single integrated resource pool. That is, even though it's made of many systems, the grid looks like a one big computer to the user, making it simple to access resources. See, SETI at home that uses a radio telescopes to search for a extraterrestrial life. That is, this project uses a grid computing to analyze the signals from space. So, computers from around the world help in this search. Astrophysics at a Swinburne studies pulsars. This is the another real example where scientists use a grid computing to study stars and space objects using a connected computing power. On the server side, the grid looks like a network of resources. That is, for the grid's backend, it's a web of computers, networks, and servers working together. Then on the client side, it appears as a wired or a wireless terminals. That is, for a regular users, it's just like opening a laptop or connecting a phone to access the grid. It is a simple and wireless or a wired access. Grids integrate computing, communication, content, and the transactions. That is, grids are not just for a computing. They also help in sharing files, communicating, and even running online services or apps. So we don't need to own the hardware here. We can rent time or resources on the grid. See, grid computing is used by companies and everyday users, and how it is used and what features are needed depends on the people and businesses using it. Moving to the next topic, grid families. This diagram shows how a computational or a data grid works by connecting powerful resources like expensive equipment, servers, and databases through a high-speed IP broadband network, which is further linked to the internet. Users with everyday devices like laptops, phones, cameras, or tablets can access these shared resources remotely. And it creates a system where multiple organizations share a computing power and data, making it possible for users to perform large tasks using distributed resources, just like plugging into an electricity grid. The grid technology requires new distributed computing models. Grid computing is not like a regular computing. It needs a new way of thinking where many computers work together even if they are far apart. Then a middleware or a software support. We need a special software that help the different systems talk to each other and coordinate tasks and share resources. Then network protocols. Grids depend on network rules like a TCP/IP to allow secure and smooth data exchange between different computers. We also need strong physical systems like computers, networks, and storage to run and support grid computing properly. So without software, hardware, and networks, grid computing won't work. These are the basic building blocks. Next is, see, big tech companies play a key role by building tools, servers, and platforms that help create and improve grid systems. Then they contribute by building tools, infrastructure, and services for grids. That is, these companies develop the technology needed to support and grow grid computing. See, just like internet service providers grew during the early web days, grid service providers are now rising to offer a grid computing as a service. A lot of new grid applications have appeared in a short time. That is, grid computing is growing fast, and many new apps for science, data analysis, businesses, etc. are being created using grids. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more insights on cloud computing, and also check out our playlist for more in-depth topics. See you in the next video.